I'm going to go over this example. So you have a similar problem of this in your homework. So over here, we need to find domain of this function, horizontal asymptote and vertical asymptote. So this type of problem will be on the quiz or test. So given you this function, we're trying to find the domain. So notice that this is a quotient. So the denominator cannot be equal to 0. The denominator equals 0 when x equal to, so denominator equal to 0 when x equal to 5 over 3. So x cannot equal to 5 over 3. X does not equal to 5 over 3. Okay. Now what happened to this square root? Well, in the square root, it's required that the radical, okay, to be greater than or equal to 0. But this is already satisfied because this is x squared. X squared is always greater than or equal to 0. Plus 1, it should be greater than or equal to 1. So there's no restriction on this x over here. So the domain here will be all real number x such that x does not equal to this 5 over 3. Now we try to find horizontal asymptote. First, remember to find horizontal asymptote, we want to look at the end behavior of the function when x going to infinity or negative infinity. So when x going to infinity, we can use our shortcut, right? We look at the dominating term, right? Square root over 2x squared over 3x. That is going to go to what? Well, square root of 2 times x over 3x. The x will cancel, right? So you see here, square root of 2x squared over 3x. That's equal to square root of 2x and then 3x. This is when x is going to be positive. And then the x here divide out, right? So that will give you root 2 over 3. So the limit over here is root 2 over 3. Just use our shortcut, okay? Now, so at this end, when x goes to infinity, the function approaching to this finite number root 2 over 3. So y equal to this number is a horizontal asymptote. So we got one horizontal asymptote. Now we try to find on the other end when x going to negative infinity and see if it approaches to a finite number. Now, as you recall that on page 8, we went over this. When x going to negative infinity, we have to be careful, okay? So, and we got this is actually negative square root of 2 over 3. It is a finite number. So y equal to this number is a horizontal asymptote. So going to this end, we have one horizontal asymptote. Going to the other end, we get another horizontal asymptote. Now, what about vertical asymptote? For vertical asymptote, you cannot reduce this any further. So remember to find vertical asymptote, you first factor and you try to reduce, divide out common factor, right? So notice that we cannot reduce this any further. Then you're going to set this denominator equal to 0. This denominator equal to 0 when x equal to 5 over 3. So x equal to 5 over 3 is one vertical asymptote. Okay. Okay, another example. This is a rational function, polynomial divided by polynomial. First, let's factor the numerator and denominator. Okay, so after you factor the numerator and denominator, before you reduce it, you should consider what's the domain. So look at this denominator here. The denominator cannot equal to 0. So x does not equal to 1, x does not equal to 2. So the domain will be all real number such that x does not equal to 1 or 2. Now, after this, you will divide out this x minus 1 up and down and giving you this reduced form. But remember, you still have this same domain here. Now, to find vertical asymptote, you will concentrate on this denominator. So the denominator equal to 0 when x equal to 2. So x equal to 2 is a vertical asymptote. Now, for horizontal asymptote, we will look at the dominating term over here. When x goes to infinity or negative infinity, this is going to dominate, that's going to dominate. And 5x squared over x squared is going to be 5. So the limit of this is equal to 5. So the y value is approaching to 5 when x equal to infinity or negative infinity. So y equal to 5 is one horizontal asymptote. So this is the end of our lesson and end of section 2.6. I'll see you guys next time.